Hi, I'm Dr. Karen. I'm making this video because a number of students in my class are having a hard time with the concept of how to add vectors. Let's start at the very beginning, because that way it doesn't matter if you don't know anything about it or not. Physical quantities come in two different flavors, let's call it. One is a scalar and the other is a vector. A scalar is something that just has a number to it. For example, temperature. A vector has both a number and a direction. For example, force. It doesn't make any sense to refer to a scalar with a direction because, 60 degrees Fahrenheit to the left doesn't make any sense. Likewise, it doesn't make any sense to leave the direction off of something with a vector quantity. That's like saying to push something but not say which direction. You have to have a direction when you're pushing. There's a couple quantities that have both scalar and vector versions. One more time. There's a couple quantities that have both scalar and vector versions. For example, speed and velocity. Okay, speed is, for example, if you're driving your car, miles per hour. That is just how fast the wheels are turning. Velocity includes a direction. You're going 30 miles an hour north. We'll talk about that kind of quantity in a future lesson. For now, let's just look at how we do math with vectors. Scalars just use regular math. You just add and subtract normally. But with vector, direction matters. So math has to be done differently. Let's take a look at how it's done. All right, let's add a couple vectors just to see how it's done. So let's say we have a vector that's 4, all right? Now, if I want to add a vector that's 3 to it, if the vector is in this, if the vector is in the same direction, they're going to add straight up as if they were scalars. So we move this over here. This is 3, and then the resultant, which is the two going together, is 7. All right? That's if these two are in the same direction. However, if they're not, if 3 goes up like this, we're not going to be able to put it over here without turning it, right? But turning it violates the rules, all right? Because whatever is going up, it says that it's 3 going up. It's not 3 going to the right, okay? So when we add this, what we've got to do is stick it on the end here. And then the result of this, the resultant, is this. Now this isn't going to be 7, right? So what we got to do is we have to treat it like a triangle. Because, well, it is, right? So we want to find out what this is. Well, there's a Pythagoras theorem, a squared plus b squared equals c squared. We've got our a and our b. Which one is which doesn't matter. And then we're looking for this one. All right? So to do this, we're going to put 4 for a, 4 squared plus 3 squared equals c squared. 4 squared is 16. 3 squared is 9. That gives us 25, which to c squared. All right? So this c, or r for resultant, is c squared equals 25, then c equals the square root of 25, which is 5. So this is 5. All right, so now we've got the magnitude, but we don't have the direction. What is this? All right, well, we've got a right triangle here. We know that the tangent of an angle is the opposite, which is 3, over the adjacent, which is 4, which is 0.75. So we take our calculator. I have the big fancy one, as you see. And we put 0.75 inverse tangent. And we get that the angle is 36.8 degrees. So our resultant is 5, whatever units this is. Let's make it right. At 36.8 degrees. So this is our magnitude, this is our direction. All right? This is what we're doing in the lab. We're setting it up like this, and we're measuring this one with a ruler. And then we're measuring this one with a protractor. All right? In step 2, we lay them out and we do the math. Let me just talk about the 2 vectors that we start with. In the lab, we have one that is 15 length. So that's the magnitude. The angle is 0 degrees. Okay? If the angle is 0 degrees, then it is right along the x-axis, right? So 15, 0 gives us something that looks like this. Okay? That means x is, the x component is all the whole thing, right? It's all in the x direction. So that means this is 15 and 0. The second vector has a magnitude of 10, and it's at 90 degrees. So that means it's going straight up and down like that. Okay, this is 10. That is backwards. And this is 10. So the x component is 0 because it never leaves the 0 part for x. And the y component is 10. All right? Now when we add this graphically, all we do is we take this vector here and we slide it over so it's here. So this is 10. And this is the vector that we are measuring. Now this vector has components that are 15 in the x direction and 10 in the y direction. So in the x direction, it's going to be 15, and in the y direction, it's going to be 10. For step 1, you measure this and you measure this. And that will give you your magnitude and your angle. When we're doing part 2, we're doing it mathematically. So this and this are pretty much redundant, this is saying going 15 in the x and then 10 in the y. So 15 in the x and 10 in the y. Okay? So we don't need that part. Instead, we use a squared plus b squared equals c squared. So the magnitude is a squared plus b squared equals c squared, which is 15 squared plus 10 squared equals c squared, or square root of 225 plus 100 equals c. Okay. So I'm not going to plug it in for the calculator for you because you got to do something, right? All right, so that is the magnitude of the resultant here. Okay. For the angle, we remember that this is a triangle like that, where this is 15 and this is 10. So we say tangent of theta, this is theta, is 10 over 15. So we hit the button that says tan minus 1. 10 over 15 is 2/3, which is 0.66 repeating. So tangent minus 1 of 0.66 repeating is, again, you can plug that into your calculator by yourself. All right. So now I'm going to cover something a little bit more difficult. Not much, but a little bit more. Okay, these numbers have all had a 0 in either the x or the y. But this works when you have vectors where there's numbers here as well. Okay? So let's look at an example. So let's have vector b be 8.5, 45, and 6 on both of these. Okay? So let's find out what the resultant is. 6 and 3 is 9. 6 and 4 is 10. So it's going to be 10 in the x direction and 9 in the y direction. All right? So now let's do the math to find out what the magnitude is. Okay, we have a squared plus b squared equals c squared. So we have 10 squared plus 9 squared equals c squared. So we have square root of 100 plus 81 equals c. Let's make it a little... Okay. So that is the square root of 181. I get out my calculator. 181 square root is 13.45. So that is how long it is. So what angle is it at? Okay. We have tangent theta equals opposite, which is the y, which is 9, over adjacent, which is 10, which is the x. So nine divided by 10 is 0.9. 0.9 inverse tangent is 41.897 degrees. So that's 42 degrees. All right. Notice it isn't these two averaged, because this one's almost twice the size of that one. Okay, we have to do it this way. So, say 13.4 and 42 degrees. Okay? So that's how you add vectors using the calculation method. Okay, now let's look at the third step, the computation of error. All right, all we're doing in this one is to compare the first and second answers that we got. Since the vectors we're adding are the same, our computation and our measurement should be very close. Okay? I'm going to say that I'm using different vectors. Don't use these numbers in your answer. I'm going to say that I measured the first one at 15 inches, and I calculated that it should be 15.5 inches. So this is step 1, and this is step 2. All right? So this is measured, and this is calculated. All right, so now we need to find what the error is, because one of these is off, right? We're off by a half an inch. All right, so how we do this is we take the difference between them. So we've got magnitude 1 minus magnitude 2. And we divide that by whatever our calculated one is. In this case, 2. Okay, these lines mean are for absolute value, which means that whatever number we get, we're going to make it positive. We're looking for the difference between the two. We don't care which one's bigger. Okay? So this equals 15 minus 15.5 over 15.5. All right, that is 0.5 divided by 15.5. Using the calculator, we have that this is 0.032. This can also be expressed as 3.2%. So there is a 3.2% error between these two readings. If your numbers are the same, this is going to be 0. This is saying that what you measured is exactly the same as what you calculated. And that's a good thing. So now, if you have any questions after this, be sure and contact me.